Hello and welcome to part 3 of this lecture on skin and eye diseases. This lecture is intended for my college students, but anyone, of course, who's interested in skin diseases, which may not be many of you, or you're studying skin diseases and diseases of the eye, welcome aboard. Hope you enjoy this discussion and get some benefit out of it. So we're going to pick up here. I started with bacterial infections in part 1, viral infections in part 2. Now we're going to look at fungal infections in part 3 and diseases of the eye as well in part 3. So let's look at cutaneous mycoses. So if it has a prefix MYC, it's going to be referring to fungi. So we're going to be looking at fungal diseases of the skin. So we have dermatomycoses, which are the tinnias, or what we call ringworm. And if it's called ringworm, you can probably guess why. People thought that there were worms that burrowed their way under the skin, and then they circled back on themselves and made these round, looked like worms were under there, circular worms under the skin, and the hair would fall out and so forth. So it was assumed that a worm somehow got in the skin and created this infection, which is not true at all. It's caused by fungi. So fungi are capable of metabolizing keratin because they possess the enzyme keratinase. And so this enzyme can break down this protein, and that's why mycoses, dermal mycoses or dermatomycoses, are common I guess not in everybody, but if you look at other infections, for example, we don't spend a whole lot of time in other systems of the body talking about mycoses, except with the skin. And the reason why, the main reason why, is because fungi possess the enzyme keratinase. And so they're capable of infecting hair, skin, and nails. All of these are repositories for keratin. So we say ringworm of the scalp and jock itch and athlete's foot, usually transmitted via fomites. So fomites are inanimate objects that can pick up the fungi and then can be passed on to others. And so that's why we associate it with locker rooms, for example, and towels and on the floor and wet, moist, humid areas. But you don't have to be a jock and you don't have to be an athlete to get a dermatomycosis infection. Treatment with topical drugs, antifungals, and oral antibiotics if necessary. So you can see in the picture of the ringworm, especially the one in the upper left there, that circular one on the individual's neck. It looks like there's a worm there, maybe. I don't know, but kind of made this ring structure to it. Athlete's foot, which can lead then to breakage of skin. You can become co-infected with bacteria as well, so you could have a fungal and bacterial infection. Tinea capitis, which is ringworm of the scalp and the hair falls out, or tinea unguium, in which you have a nail infection and it causes yellowing and the flaking of the nails and the breaking of the nails. The fungi are in there metabolizing the keratin and causing the nail to kind of fray and break apart. A subcutaneous one. So now sub means under the cutaneous membrane. This would be a subcutaneous mycosis, and we'll just look at one spore, trichosis, caused by a fungus called Sporothrix schenkii. From soil, it enters a puncture wound. And this this fungus exhibits dimorphic growth. Di meaning two, morphic referring to shape. So it takes on these two shapes, which makes it more pathogenic. At our body temperature, it grows like a yeast. Cooler temperatures, it grows like a mold. So it has, with the yeast-like growth, it sends out what are called these structures that are called pseudohyphae, which can penetrate tissue, and it makes them more pathogenic and can spread through tissue more easily than whenever it's at cooler temperature growing like a mold with filamentous growth, not capable of penetrating tissue nearly as well as these pseudohyphae. So this is not just exhibited by this fungus. I mean, other microbes are dimorphic as well. Often enters the lymphatic system, as you can see in this, I'm going to say this kid, I guess, kind of looks like a teenager maybe, in the lymph nodes on the neck there, and it looks like it broke through the skin as well. It's treated with potassium iodide, and potassium iodide is a pretty effective treatment against it. Candidiasis caused by yeast, Candida albicans, and it may result from suppression of competing bacteria by antibiotics. So this could be an opportunistic infection. It's got the opportunity now. There aren't bacteria there, and so now yeast can colonize. And the reason why it happens, like if you develop a yeast infection, a vaginal yeast infection, because the pH rises, because the lactobacilli that are in that region are keeping the pH rather low, like a pH around 3. Whenever the lactobacilli bacteria are, their numbers go down, pH goes up, yeast thrive at a pH of 5, and voila, there you have a yeast infection. So it occurs in skin and mucous membranes of the genitourinary tract and in the mouth, and in the mouth we call it thrush, where the yeast are growing in there. Often infects immunosuppressed, and thrush can be as often actually seen in newborns because normal microbiota have not yet been established in the mouth. Like, for example, when we were talking about the bacterial skin infections where you have impetigo of the newborn, the normal microbiota on their skin have not yet been established, and so Staph aureus can take hold and really grow. This happens where yeast now can really grow in the mouth of newborns because they don't have all the bacteria in their mouths that would prevent their growth. And topical treatments, OTCs, are used to treat yeast infections. And there you can see what yeast look like under the microscope, and there's a picture of thrush, which doesn't look very pleasant. So that's it for fungi. Let's look at some parasitic infections. We'll look at first one, scabies. Scabies are caused by a particular species of mites that can only reproduce on human skin. The scabies mite burrows in the skin the female does to lay her eggs, and this yields or results in intense itching. It's the eggs themselves and also I guess you could say the fluid around the eggs as well. Develops or yields and causes intense itching with people that do develop these. I guess you could say an infestation. It's not really an infection because it's not like it's bacterial or viral. It's transmitted through intimate contact, and so skin-to-skin contact. Treatment with topical insecticides, about 500,000 cases in the United States per year, which when I saw that when I first was putting this together, I thought, boy, that was more than I thought. So about 500,000 cases per year. A rare condition or a more advanced one here, a rare or more advanced, is called crusted scabies or Norwegian scabies or the 7-year itch. This is only seen if the immune system is weakened, and the skin, as you can see on the hands of this individual, get severely crusted over, and in those thick skin crustaceans, it's not the right word, but you know what I mean, under all that crustiness, there would be a bunch of mites and also thousands of their eggs as well. How do you treat this? Well, it's usually topical. It's going to recommend getting rid of all that crusty skin because topical insecticides are not going to be able to penetrate through all that thick, crusted over skin, and so the individual is advised to remove all that thick, crusty skin before the topical insecticide can be applied. And this can go on for weeks, for months with treatment. It's very difficult to get rid of it when it reaches a stage, and the reason why is because of the weakened immune system. You're relying on the insecticides more than your own immune system, and so this becomes a very persistent infestation. Lice. We've had to deal with lice in our family. An outbreak at our daughter's school, and a very tedious thing to have to get rid of. Head and body lice. So you have there's a species that lives on our hair and a species that lice on our body as well. They're both different. No disease is spread by the lice that live on our hair. The lice that live on our body, yes, epidemic typhus is the number one disease that's spread by human body lice. spread by direct contact. They feed on blood, and they lay eggs, which are called nits, on our hair. And you can see what they look like. There you can see it under a scanning electron microscope in the lower left. Um, on the lower right, that's what Mama Louse looks like. And then in the upper right, that would be an egg case. A nit is on a hair shaft. And you can see that it looks like it's popped its top and it's ready to come out. So you can treat it with topical insecticides and or use a louse comb. We used hair straighteners and shampoos that you can't use very often because the chemical compound that's in it, you just don't. It can be toxic if it's used too frequently, and so it's recommended to not be used frequently at all. In fact, just twice at a time, and then you have to wait a number of months before you can use it again. But it's a pain. They're hard to get rid of. They're hard to see. They're quick. You wouldn't think that they would be very quick moving little critters, but they are. So this is where we would find them in our hair. So we're going to look at microbial diseases of the eye. So first we'll look at conjunctivitis or pink eye. You have inflammation of the conjunctiva, enzinitis, so it's inflammation caused by various microbes and allergens, and so this could be a number of different allergens that are causing it. Associated with unsanitary contact lenses, which in this day and age of disposable contact lenses, the number of people developing conjunctivitis because of the contact lens has gone down dramatically. When you had your contact lenses and you wore them for a month at a time or even longer, conjunctivitis was becoming more common. But disposable lenses have been very helpful in reducing the numbers of pink eye. Neonatal gonorrheal ophthalmia. So this is transmitted to newborn's eyes during passage through the birth canal by the bacterium Neisseria gonorrhoeae. And so this gets passed because mom has a gonorrheal infection. As the child is born vaginally, it picks up these bacteria. The bacteria then colonize the newborn's eyes, and then they develop this gonorrheal ophthalmia. Generates large amounts of pus that become crusted over. We treat the newborn's eye with antibiotics. We did use a silver nitrate solution in the past, which was very effective in killing the bacteria, but many times mom is co-infected with other bacteria such as chlamydia, and so silver nitrate doesn't work against chlamydia, so now we just put antibiotics on, broad spectrum antibiotics, to kill a number of different bacterial species, and that has been very effective in preventing the transmission of this. So you can see pink eye there on the left. I've had pink eye once, maybe twice. Not too bad. Inflammation, itchy, uncomfortable. And then you can see what the bacteria do there, the gonorrhea bacteria on the newborn's eyes. Thick, crusted over. The eyes would be red underneath there and painful. Inclusion conjunctivitis. So this is transmitted to newborn's eyes as well during passage through the birth canal, but this is not from gonorrhea bacteria. This would be from other species, spread through unchlorinated swimming pool water as well. So they reside in the pool water that's not being treated properly, and then can get in the eyes of people that are swimming in that pool. We can treat it with tetracycline. Trachoma, which is bacterial, caused mainly by chlamydia. It's the greatest cause of blindness worldwide. Repeated infections, what happens is it causes permanent scarring because the eyelashes turn inward due to the inflammation, and every time you blink, it rubs your eyes. It becomes incredibly itchy, I assume, and you rub your eyes some more. You're rubbing your eyes, you're touching your eyes, you're getting the bacteria on your hand, and so of course that leads to spreading of the bacteria as well. But the rubbing creates more scarring and more scratching and abrasion to the cornea, and that can then lead to blindness, which is called trichiasis. Transmitted mainly by hand contact, sharing personal items, and flies. Flies land all over the faces of people with trachoma. They pick up the bacteria. The flies then land on somebody else's eyes, and then they transmit the bacteria to that person. And so this is how it's getting spread around. That's one of the ways that this happens. But it's the number one cause of blindness. So you can see trachoma there on the left. A person is holding up the eyelid, otherwise it would turn downward. There's inflammation. And then trichiasis, you can see the clouded over scar tissue on the cornea, and so that creates blindness then as a result of that. According to the World Health Organization, 2.2 million people are visually impaired because of trachoma, of whom 1.2 million people are blind from it. It can be prevented. It's pretty easily treated. However, people who get it are in impoverished nations. They don't have easy access to medical care, and they don't have access to people with knowledge of how to treat it, and so it unfortunately spreads pretty rapidly. Herpetic keratitis is caused by HHV1. It's the same one that causes cold sores. So it goes latent in trigeminal nerves, and if it travels, as it travels down the trigeminal nerve, it can get into the eye because the trigeminal nerves serve around the eye as well, and it can infect the cornea, may cause blindness because of deep ulcerations that are resultant from the viral infection. And one that's caused by a protozoan, an amoeba, called acanthamoeba keratitis. It's an amoebal infection through contaminated water. So amoeba have been released into the environment through fecal matter. It gets into a water supply, and then the individual then can, the amoeba get onto the eye and just pretty much destroy the eye. It's the only way to really fix it is a corneal transplant or just removal of the eye altogether, and you end up with a glass eye as a result of this amoebal infection. So you can see on the left, herpetic keratitis, you can see that there's ulceration and the cloudiness of the eye as well. With the acanthamoeba, the amoeba creates a cyst in the eye, which then just destroys the cornea, and that of course then causes blindness. So that's the end of part 3. That's the end of the chapter on just a quick overview of microbial diseases of the skin and of the eyes. Just a survey of all the different types of, not all the different types, but a number of different types of infections there on the skin and the eyes. So I hope you enjoyed this discussion. I hope you learned something from it, that it was educationally worthwhile for you. And as always, I thank you for watching, and please subscribe and share this video with others who you think may benefit from it.